Hello everyone, my name is Tuan Lung Quang. I'm working for TÜV Süd, a German independent technical inspection company. And besides that, I am also the product manager of openPASS, which gives me today the opportunity to give you a short overview of openPASS. So openPASS is a simulation platform used in the field of autonomous driving. And to enable cars to drive autonomously, they are equipped with advanced driving assistance systems, short ADAS, and autonomous driving functions, short AD functions. So those systems and functions, they are responsible for our safety, for the safety of the car, for the passengers, and for the surrounding. And this is the reason why it is necessary to assess those systems on their effectiveness. And here is where openPASS comes into play. It stands for Open Platform for Assessment of Safety Systems. So the question is now, how do we assess the safety of those systems? Our approach is to perform traffic simulation of highway, rural, and urban scenarios. But you don't want to have one single scenario which you are simulating. You want to have multiple ones, because for each scenario, the ADAS or the AD function behaves differently. And that's the reason why you obtain different results for each scenario. So you don't want to perform one single traffic simulation of one scenario, but of multiple scenarios. And one way to do this is to apply stochastics, because over stochastic variation, you can get different scenarios while you are varying, for example, the vehicle speed, the vehicle positions. You vary all those parameters, and then you get multiple scenarios which you can access each. One goal of us is, as an open source tool, to get a high acceptance in the automotive field. We are reaching this by using standardized interfaces. Over those interfaces, it is easier for the user to integrate their models into openPASS. Also, being in a virtual environment has the benefit of reproducible simulation outcome. So you are going to hear a lot of presentations on the Eclipse conference. When you hear about openPASS, memorize that this is a simulation platform for the effectiveness assessment of ADAS and AD functions. So I was talking about a high acceptance in the automotive field. openPASS is used already in several projects. Here is a short overview of just some of them. For example, VVMethods and Z-Level are both German-funded projects. VVMethods deals with the questions or has the goal of developing a method on how to prove safety autonomous vehicles level 4, level 5 in an urban environment. And Z-Level has the goal to enable simulation to test autonomous cars for level 4 and level 5. And both are in the Pegasus family. So both VVMethods and Z-Level are successor projects of the Pegasus family, which has more topic for level 3 vehicles. The OSCCAR project is a EU-funded project and deals with the question on how to make cars safe with different seating positions for the passenger, because in the future the car interior and especially its sitting positions are going to vary from the sitting positions like we are knowing today. And also openPASS is used in the EU-funded project Virtual. There openPASS was used as an enhanced open source framework to investigate accidents between cars and pedestrians. They simulated over 100,000 scenarios and assessed each of them. So as you can see, it is openPASS is already used and already an accepted platform in the automotive field. So TÜV Süd is not the only member in openPASS. Luckily, we also have driver members, user members, and service providers. So we have different kind of memberships. Driver members are the BMW Group, Bosch, Mercedes, TÜV Süd, and Volkswagen. We have one user member, Toyota, and one user member, one service provider, ITK. So, and each member has some kind of different interests. So driver members are more interested in the future roadmap of openPASS. User members more interested in using the simulation platform, and the service provider, ITK, is more interested in the technical implementation. In the Eclipse universe, we are not the only open source project which deals with automotive topics. On the right side, you are seeing other projects. On Monday, there was the community day at which every project had a short presentation. So we are not alone. We even have our own top level project, which is named Eclipse Automotive Top Level Project. Okay, now let's come to the platform concept and how we realize the idea and objectives which we are having. In the middle, you can see the simulation core of openPASS. It is the heart of openPASS and does all the calculations. It does the calculation for the vehicle dynamics, simulation steps, and so on. And now the key idea is that over standardized interfaces, you can connect, we call it agent components, to the simulation core. Agent components can be driver models, vehicle models, sensor models, and automated driving functions. And we provide simple examples such that the user get a better understanding and an easier introduction into openPASS. And the benefit of it is its modularity. So we provide simple examples, but the user should provide their own, or can provide their own models, their own driver models, vehicle models, to connect their models to openPASS. And through the modularity, such an exchange of those models is possible. And a benefit of this approach is that usually the models are kind of secret, and the user don't want to reveal their models to the public. And over this approach, the user can use an open source tool, which is publicly available for everyone, but keeping their models secret and don't reveal it to the world. Similar with the scenarios. We provide simple examples of scenarios which are connected to standards, to the simulation core, but also here the user can provide their own scenarios. What can you do with the simulation output, with the simulation results? You can do accident research, functional development, safety performance assessment, virtual testing, and homologation. So I was talking about standards. Which standards are we supporting? We are supporting Open Scenario, which is a scenario description language, which describes, as the name is suggesting, the scenario of openPASS, the scenarios which openPASS is simulating. Then OpenDrive, it's a standard to which describes the road environment. OSI, Open Simulation Interface. Over that, you can integrate your models, especially automated driving functions. And FMIs, Functional Mockup Interface. With that interface, you can integrate FMUs, Functional Mockup Units, which in this format are the most models. Okay, let's come to the platform structure. So how do we realize the platform concept, which I have shown you? The platform is divided into mainly two parts: the graphical user interface on the left side and the simulation core on the other side. The simulation core again consists of simulation components and agent components. The simulation components are responsible for calculating all the simulation steps. And the agent components, I have already explained it to you. We provide some examples, but the idea behind it is that the user can and also should provide their own agent components, which is possible through our modular structure. On the other side, we deliver some plugins over which you are setting up your simulation, but also here the user can specify their own plugins. So some examples to get a better understanding: simulation components can be a spawner, an observer, detectors, manipulators, and the world state. Let's take as an example the spawner, which is responsible, as the name is suggesting, spawning all the vehicles on the road. Exemplary agent components can be sensor models, algorithm dynamics, and on the other side, the graphical user interface is already delivering some plugins. For example, an agent configuration, which is, with that, it's able to configure your agents. Okay, let's come to the simulation process. From the user's perspective, it's kind of straightforward. You configure your simulation setup through the graphical user interface, but actually it's also possible to set up your simulation through the configuration files, and the graphical user interface does nothing than writing those configuration files. But this is more for an advanced person to write directly into the configuration files, I would say. Then openPASS takes the configuration files and does the simulation for you. As an output file, you are obtaining CSV files and XML files, and then you can evaluate your simulation in the graphical user interface. To get a better understanding of openPASS and what openPASS is capable of, I've brought two use cases, two examples for you. If you have a look on the right bottom figure, you can see a highway scenario. On this highway, you can see a green car, which is our eco vehicle, and this vehicle is equipped with an ADAS. In this case, an AEB system, an automated emergency braking system. This system is braking when it detects an obstacle in front of it, and if the obstacle is too near, when a dangerous situation is happening, then the system is braking. And in this highway scenario, a lane change is happening from another car, so the car is driving into the lane of the green car, and the other cars are spawned by openPASS. And here you have a closed loop simulation. And the idea behind this scenario is, so why are we simulating this use case is because I said it in the beginning. Sorry, I said it in the beginning that we want to assess the driving functions. I'm sorry, I need to drink something. To assess the advanced driving assistance system, in this case, the AB system. And depending on the scenario, the system is braking. And with openPASS, it is possible to simulate faster than real time. And with stochastic variation, you can vary the vehicle speed, the vehicle position, and then you obtain multiple different scenarios, and you can assess each of those scenarios. Okay, this was the first example. Now let's come to the second example, the crash resimulation. So in this case, we are resimulate a real accident which happened in the real world. So this accident is coming from a database, the so-called GIDAS database, and it is containing PCMs. A PCM is a pre-crash matrix, and it describes the phase right before an accident. So those are real accidents which happened in the real world. They were encoded in this PCM format, and now openPASS is replaying those accidents. And the key question here is, could have the AEP system or new technology avoided this accident which happened in the real world? And in my own words, it's like driving into the past, change the technology of the vehicle, and maybe this technology could have been prevented. This accident could have been prevented. Okay, so here I have brought two visualizations. Here I have to say those visualizations are generated by an external tool and not by openPASS. On the left side, you have a visualization of the first use case. The first use case without an AEB. So you can see on the highway, the red car is crashing into the other car, and you have an accident. On the other side, the red car is equipped with an AEB, and here you can see the accident could have been avoided with this AEB. So the AEB is braking and everything is good. The second use case, we have crash resimulation, and here you can see an intersection in an urban environment, and those vehicles are crashing, and also and in this case openPASS is even simulating the post-crash behavior. Okay, so now a little bit to the history of openPASS. We were founded in 2016 in August, and over the years several different members have joined our working group. We had our initial commit in 2017, and over the years we have released several versions, but as you can see, we are still working on the release version 1.0, so there's still a 0 in front of the dot. Last year I had also the honor to hold a presentation on the Eclipse conference. It was 2020, and since then we have released two different versions, the version 0.7 and the version 0.8. For the 0.7, I would say the main new feature was that we are now able to simulate urban scenarios. And the focus for the release version 0.8 was the quality. That means We have rewritten our documentation. We made the installation process easier, but also new features came for openPASS. For example, we extended our support for standards for OSI and FMI, and a lot of many new features came with the version 0.8, or are coming with the 0.8. What are our future plans? Of course, we want to increase the quality of openPASS and add more features. Besides of that, I also want to present you 2 new projects which were generated while facing some issues. So while using an interface for OpenScenario, we have faced the problem of each time OpenScenario is adding a new feature, we have to work on openPASS and update it. So this is causing a lot of work, and that's why we came up with the idea of a modular approach. That means we are outsourcing an scenario interpretation to a standalone scenario engine, which you can see on this figure. And the scenario engine is parsing and interpreting the OpenScenario file, gives that information over an interface, a mental API, to the simulation core. And the key idea behind this approach is that you can exchange the engine depending on your scenario description language. That means if you have on the left side another language, you just change the engine, and then you can interpret and parse that new scenario description language. Currently, we are working on a 1.0 engine, and we want to update it on the short term to the 1.1 engine. And on the long run, when OpenScenario 2.0 is released, we want also to have a 2.0 engine. And the API is the interface between the engine and the simulation core. And with that interface, that modular approach is capable. The shown figure is work in progress, as I said, and hopefully maybe on the next Eclipse conference I can show you an update of our plan. Okay, so we are always looking for new members, and if you are interested to join openPASS, you first have to become an Eclipse member, and then you can join openPASS. And you can discuss with us the roadmap, collaborate with the working group, and work with us together. My name is Tuan Dung Quang. I'm the product manager of openPASS, but luckily I'm not alone. There's also Jan Doberstein, who is the speaker of the steering committee, and Arun Das, who is the speaker of the architecture committee. If you have any questions, you can always contact any one of us. Okay, now let's come to our conclusion. So openPASS is an open source simulation platform for the effectiveness assessment of ADAS and ED functions. And I have shown you that our objective is to become an accepted simulation platform in the automotive field. And how do we get to this goal? How do we get to this objective? Through our modular structure, such that the user can use their own models while using an open source tool. Furthermore, through our standards and standardized interfaces, we are having a flexible simulation setup, which makes it also easier for the user to use their own models. And I have also shown you 2 exemplary applications of openPASS, the traffic scenario simulation and also the crash resimulation. Okay, that was everything from my side. And if you have any further questions, or if you have any questions, now is the time to ask them. Thank you. Okay, so hi everyone. So this was a pre-recorded talk from my side, and now we are coming to the Q&A part. And yeah, if you have any questions, please write them in the chat. And actually, there are already some questions. So I'm just starting from the top. And I'm going to read aloud every question, such that you also know what the question is about. So the first question is, as a newcomer interested in openPASS, what is the best way for me to get started? Okay, so for the attentive listener, I have mentioned in my talk that the focus of the version 0.8 was the quality. That means we have been working on the documentation and installation guide, which makes it easier for the user to get an easy access to openPASS. So yeah, the most important parts should be documented. So I would start looking into the documentation and download openPASS from our GitLab site and try it out. You are not losing anything because it's open source, but I'm pretty sure that you will face some challenges of using openPASS, and if you do so, you can always contact me or contact the working group as shown in the slides. And this is the way I personally would start if I am a newcomer. I hope this answers the question. The second question is, what is the difference between openPASS and other simulation tools like Sumo? Okay, interesting question. Maybe to Sumo, it's also an open source tool in the Eclipse Foundation. So I think the scope of both simulation tools are different. So Sumo has more the aim of simulating whole cities. So bigger scenarios. They are also able of simulating buses and other big cities. And openPASS, really the main focus is on safety assessment. So and it's important in the field of safety assessment that when you are simulating something, it should be 100% or 100% correct. So our focus is not simulating big cities, but when it comes into the detail and into the microscopic area, then openPASS is the tool to choose. Okay, there just came in a third question. Is openPASS in direct competition with commercial simulation tools? So openPASS, I wouldn't say it's in competition with commercial tools. It sounds, because in competition everyone can use it for free. We are glad if you're using it, but the benefit of an open source tool is that you can have a look inside the tool. So every line of code can be read by the user, and in comparison, in a commercial tool, it's probably mostly kind of a black box. Okay, so I have to look at the time. So the Q&A session is limited to 5 minutes, and I still have 1 minute. Well, now it's actually over, and thank you for your questions, and thank you for listening to my talk, and see you maybe next year. on the Eclipse conference. Bye.